Good evening, everybody. Technology is working, it's a wonderful thing. Right. Yeah, no. Anyway, thanks all for coming tonight. Slightly smaller audience than may we sometimes have, but had this promoting this event over the summer and stuff. But those that have not come are going to miss out on a real treat. That's why I can tell you, aren't they, Kornel? There you go. So there you go. Right, so just some quick things for those, if there's anyone here who's not been here before. Toilets are out across the way on the corridor. If there was to be a fire alarm or anything like that, you have to go out via the stairs. Don't try and use the lifts. That's health and safety done. Tick. And basically just some a notice of what we've got coming up in the next month. It's actually going to be a good friend Adam Anishi at the back, who's going to do a preview of his Velocity talk that he's going to be doing in Amsterdam, which is all about the development of the London Web Performance website. Because foolishly, Adam actually agreed to build it for us. And of course, being a web performance group, it had to be performant, right? Right now, we've got, there are a couple of optimizations we've still got to do, which are on the to-do list, but hopefully they will be done by the time that we do the talk, and certainly by the time that we do it in Amsterdam. Because there's no pressure, Adam, on that one. So me personally, I'm really looking forward to that one, obviously. So that's what's going to happen in October. Beyond October, I'm just kind of lining up some new talks currently. So, but if there are anybody out there that would like to do a talk or know someone that you think could be great to have here and speak, do come and tell me about it, because we can try and get that sorted out. But there's opportunity going forward. As we kind of work towards Christmas, we'll probably do another one of our famous quizzes, which Andy always wins, right? So he's going to start with a handicap of -10 when we do the next quiz. That could be a challenge, yeah. I'd bet you a pint on that one. But there you go. Anyway, so that's kind of what's happening. Basically, tonight, Kornel's going to talk everything about snake oil and image compression. I think, was it a year ago or 2 years ago that you gave the last talk at the group over at Twitter? But yeah. So it'll be really interesting if you came to that meetup at that time. Kornel talked a lot about PNG compression and some really funky things that was going on with image compression, and so it'll be really interesting to see how things have moved on and stuff going forward. It'll be really good. Just really looking forward to this talk. So at 8:30 there'll be pizzas as usual. So we've got plenty of time for questions after the talk up until that time, and I hope you stay behind and have a beer and socialise after the talk. So right now I'll hand over to Kornel, and he'll tell us all about this snake oil.
All right. Yes, so I work on ImageOptim, PNG Quant, and a couple of others image compressors. So I need to know what is good compression and what isn't. So I wanted to share that because it's not very well known how to actually benchmark and measure good compression. Now, if you've been to previous web performance talks, you've probably heard the statistic that images use 2/3 of average website's bandwidth. And compressing images well is critical to website performance. And the better compressor you have, the faster loading website you'll have, and the less expensive to host and load for your users it'll be. And there are many tools that promise to do exactly that. There are several image formats that you could use. But how do you know which ones are actually worth your time and which ones will really improve images? Now, I could just list them and tell you. But the new software comes out regularly, new formats pop up. So instead, I thought, I'm going to show you how to do the benchmark yourself, how to do real proper comparison of image formats, so that when somebody tries to sell to you the next best image format, the next new cool compression service, you will be able to have a real objective, scientific measurement of what they're really doing, rather than just relying on their marketing material. Starting from the beginning, we have two kinds of image compression, and it doesn't really help that both of them have loss in the name, even though they're completely opposite things. So for lossless image compressors, the situation is very simple. Because quality does not change, you have only the one other variable to compare, which is file size. So you pick the one that gives you the smallest file size, and that's it. If my talk was about lossless compression, it would be over now. So for the rest of the talk, let's focus on lossy compression, because this one is tricky, because both quality and file size changes at the same time. Now, the idea behind lossy compression is that eyes are imperfect, and the details that are too small to be seen can be replaced with rough approximations. Like I did with that small text, where I've replaced half of it with gibberish, and you didn't notice because it was just too small. And I've checked, the second half really compresses better. So the first point is the perceived quality depends on viewing distance. Let's look at comparison between super high quality image, the original, and I've compressed it using latest, greatest FLIF format, which is top-of-the-line lossless image compressor. So it exactly preserves every pixel in the image, every speck of the dust in the photo. And the one below is in GIF. It's 64 colors, it's deterred, it is supposed to look awful, but from that distance, you probably don't even see how dramatic.
About my shirt.
Yeah, but from this distance and on the projector that has low contrast, you probably don't even see how dramatic the difference is. But if you view this on your personal computer screen, you would notice that, well, you know how GIF images look, generally terrible and deterred, and this one is no exception.
Not even 4K can render your shirts, Barry.
Right. But here's the interesting thing about lossless and lossy formats. Top is the best lossless format we know currently, and the top image takes 230 kilobytes. The bottom is probably the worst image formats that we have currently, and it's over 10 times smaller. And it's not because GIF is good. GIF is terrible at everything it does. It's just because so much of the quality was lost, just thrown away and ignored by the image format, and not storing the information is better than compressing it well. So lossy compression is about losing the information. But it's mostly about losing it in a clever way. Because if we took the same image in JPEG, it would be both smaller and higher quality, simply because JPEG is much more clever at which pixels, which details are kept, and which ones are thrown away. But then, what if that JPEG was 30 kilobytes in size? Would you say it's better? It would be losing on the file size. So just looking at the file size, it would be worse. But obviously, it looks better. So is it worth it? Could you, for example, save GIF with more colors, but still under 30 kilobytes? Would it change the picture? Well, I kind of spoiled it saying that GIF is the worst, so you know it won't. But if you were comparing two tools that you don't know, or the difference wasn't so big, then you would have to have a careful look at the difference. And it's done this way. First, we're going to graph. Oh, wrong way, sorry. Going to do a graph of quality to the file size. There we go. So when you save an image, you will be asked to set a quality. You save an image, and you look at the file size you get. You choose another quality level, make a note of the file size, and if you repeat this enough times and graph it, you'll have an idea of what, for that format, for the image, for the tool you're testing, you'll have an idea what's the relationship between the quality and file size for that format. So whenever you're comparing tools, it's really, really important to check that at multiple levels, because if you're just comparing two images, it may not be possible to have a really, it may not be possible to have a good answer. There are only two specific cases where it's valid to compare just two images with each other. The first case is if the quality is exactly the same. And if the quality is exactly the same, you can obviously compare the file size, and the one that has smaller, it's fine. That's the special case of lossless image compression. But with lossy formats, it's actually sometimes really hard to get them at exactly the same quality, especially if the distortions look different. So then it's just a very subjective call, which one is worse and which isn't. Or for example, imagine you're saving a JPEG at quality 65, 70, and 75. If you shuffle them around and then look, will you be able to immediately see which one was the worst and which one is the best? We are not that precise in judging the quality. So I'm going to show you later how to do that very precisely. The other case is if you save two images at exactly the same file size, then you could just subjectively pick the one with you think has better quality. And when I mean same file size, I really mean exactly the same file size. Because for very good formats, they might be saving images at 1 bit per pixel. That's like if the image was uncompressed, it would be just black and white bitmap. But the formats like JPEG are able to store a full color photo in the same amount of data as was used for, say, a screen of old Macintosh. So this is amazing, but because it's such a high compression at 1 bit per pixel, if you compare two images and you find that maybe 8 pixels are a bit off and should look better, you never know whether if you made the file 1 byte larger, would it actually fix those 8 pixels that you didn't like. But most of the time, you end up with a situation where you have your original high-quality image with massive file size, and you have some tool or service that makes it much smaller, and the image still looks almost the same, a little bit worse, but almost the same. And then you want to know, is that good? Is that really worth it? If the relationship between file size and quality for your format and for the new one you're evaluating looks like that, then yes, definitely the new one is better, because in the new one, even if you increase the quality, you would still get the smaller file size. But here's the trick. Just having two images at two different file sizes at two different qualities, the relationship could just as well be exactly the opposite, given the same two examples. So the opposite conclusion could be that, no, the new tool is actually worse. It's just degrading your quality without giving you any benefit, because instead of adopting a new tool, you could take your original one that here's in the red and just lower the quality yourself in the first place without switching to a new tool. So having just two images that are not either at the same file size or either at the same quality, it's impossible to tell. So you need more examples. And the real world is even worse. Very often, you'll find that the relationship between file size and quality is all over the place, and those curves might even cross, which will mean that one tool, one format, is the clear winner for high-quality images, but the other tool or the other format is actually better for low-quality images. So you cannot even clearly say, without qualifying it, whether one is better on the other. It very depends on your use case. When you read blog posts introducing new image formats, you'll usually find the new format shown you at the lowest possible quality compared to JPEG at the lowest possible quality. So we can see the new format being all smudgy and blotchy compared to blocky and posterized JPEG, for example. And you might be thinking, yeah, now I see the performance of those formats, and now I can see how they distort images. But actually, you might be seeing this case where they perform differently at the low quality, and it's not representative of the real use case where you might want to have image at the high quality where the distortions are not visible. So you might be like the guy in the joke who lost his wallet way over there, but he's looking here because that's where the light is. So you might need to have high-quality images without visible distortions, but you would rather compare the formats or the tools at the lowest quality where you can clearly see how they distort images. Now, I've said quality probably 100 times now. And the quality is a weird thing. Now, in most formats or tools, you might see quality represented as a slider. It goes from 0 to 100. You pick one number. The problem is this is completely made up. This has no relevance with any physical or any objective property of anything. It just tweaks some variable in some algorithm inside that program, which has been just written and invented by an engineer. So this is as meaningful as the volume knobs. And I could just as well write my own software where quality goes to 110. But it won't mean that my software has better quality. It will mean I just tweak the numbers differently in my program. The other side of the scale is also a nonsense. So take an image, save it at the 0 quality, and then let me scribble over it with crayons. I can bet you that I can make this image look even worse. But does that mean the image has now negative quality? Is there even such a thing? Of course not. So to compare a quality across different formats, across different tools, we need another approach. And how it's usually done, we take the original uncompressed image. And it's important to start with like pristine copy without any distortions. And we compress the image. And then we ask the tool, how big is the difference between those two images? And the tool will output a number, also in arbitrary scale, but you can use the same scale for multiple images. So then you can compare those numbers. And OK, well, difference between this and this is 1.1. This one is 3.5. So the other one is worse. And it gives you some kind of objective number that is easy to compare and is easy to apply it to hundreds of images. Now you might be wondering, why not just ask people? Ultimately, we're compressing images for people, so their eyes ultimately are to judge this. This is because people as a measurement device are slow, imprecise, and expensive. So yes, if you ask 100 people about their opinion of quality of an image, you'll get some sensible, useful numbers. But if you just ask one person, it will depend how well they can see, what was the lighting conditions in the room at the same time, how well their monitor was set up, or even completely subjective preferences. Maybe some people like sharp images, other people like smooth images. So for practical purposes, to avoid having to ask 100 people or rely on somebody's completely subjective opinion, we use tools for that. The most popular, especially in anything vaguely scientific or academic, is called signal-to-noise ratio, also mean square error, which is another side of the same coin. And it's a measurement that's very simple, elegant, and wrong. The problem with this, it compares image pixel by pixel with a simple mathematical formula, so it's very appealing. But humans don't see every individual pixel in an image in isolation. So if I take a screenshot of a text and compress it heavily so it's distorted, you will definitely notice this because you have a clear idea how each letter should look like. But if I apply the same compression with the same strength, the same deformations to a photo of a brick wall, you won't mind because you don't care about every tiny detail in a brick wall. So that's why peak signal-to-noise ratio is not that good. If you've ever wondered what happened to JPEG 2000, there was the classic JPEG and 2000. Why aren't we using the new shinier thing? Well, PSNR happened. JPEG 2000 was optimized to win in benchmarks on signal-to-noise ratio. And signal-to-noise ratio really, really likes blurry things. It rewards removal of details. So that's what JPEG 2000 was good at. It was good at smoothing out details from images. But it turns out in real world, we have things like people's faces with skin, with texture, fabrics or walls that have subtle noise. And if you blur this noise away, people start looking like androids, and everything looks like plastic. And this is just not a good idea for a codec. So that's why, even though JPEG 2000 got standardized because it won on paper, it's mathematically closer to the ideal, it lost with people because it just made everything blurry. Our industry has learned on this mistake and switched to structural similarity as a tool for comparing image formats. And structural similarity is not as mathematically elegant, and unfortunately, there are even multiple slightly different ways to compute it, so different tools will give you numbers on a different scale. But on the upside is, structural similarity is aware of contrast. It's aware of how we perceive things in bright and dark areas. And it's very good at detecting noise and blur and distinguishing them from each other. So peak signal-to-noise ratio had about 30% correlation with actual human judgment. Structural similarity goes up to 70% correlation with human judgment. So it's much more in agreement what people actually think about image quality when you ask them. There are multiple versions of structural similarity, slightly better, slightly worse, depending on what you use them for. And there are a couple of other algorithms that work on the same principle, are just implemented differently. So as long as you use something better than peak signal-to-noise ratio, it's going to be fine. Now, there are a couple of questions with image comparison that still haven't been answered, and it might seem like a really basic thing. Color. It turns out human perception of color is a subject of many weird optical illusions that nobody had put as an algorithm nicely yet. So all those tools just ignore color, hand wave it, like if it works for grayscale, it's probably fine for color too. Or compare RGB channels, which is not quite fair because eyes are much, much less sensitive to the blue channel than the green one. But, well, that's what we have. An alpha channel, if you need to compare transparent images, you'll probably just have to blend them with some arbitrary background and compare that. Because there's no tool that does it well. And I haven't even seen research on transparent images. So I don't know how you would do that. I've tried to make a good tool for image comparison. It's DSSIM. It tries to do color properly. It tries to do alpha. It's not great, but it's the least bad I know. So with that, let's see how it looks, how it actually looks when it's applied. So this is a chart. The scale is a bit off, but logarithm of DSSIM score. It's very common to do logarithm of scores to avoid charts getting really tall and unreadable. because these tools just output numbers all over the place. And sizes are given in bits per pixel, because that's just independent of the image size. And that's the quality to file size ratio for JPEG. And this actually gives rather realistic picture of JPEG, where as the file size goes down, it has good quality, and then just collapses. And it becomes a blocky, awful mess. So let's compare it now to the same graph of WebP. And now we can see the WebP, yes, actually wins over libjpeg, and it's always on the top. So whether you want, whether you're OK with large size, you get higher quality, or whether you want to minimize the file size, you get still smaller file size at the same quality. But it's comparing with libjpeg. Libjpeg is used by ImageMagick. libjpeg is used by all the plugins built into PHP or Python. Photoshop, say for web, uses something similar that has almost the same result. But libjpeg is a bit of piece of software that had last major release in 1998. Since then,
it's still better than doing nothing at all.
Oh, of course,
right?
of course. But yes, another thing that you can notice in the chart, that changing quality of JPEG itself has a huge impact on the file size. And the difference between file size between JPEG and WebP is that small. But the difference in file size between high-quality JPEG and low-quality JPEG is that large. So just switching to another format and serving it at excessively high quality will not help you much. The biggest saving is actually from getting quality right at the absolutely lowest level that you think is still OK. Right, but even in JPEG compression itself, the whole point of the exercise is we want the maximum quality for minimum file size. There's MozJPEG. It's the new JPEG encoder developed a couple of years ago that brings some of the new compression techniques in a backwards compatible way. So it produces still JPEGs that work with every piece of software except Adobe Bridge. But they work in all browsers. When we look closer, at the low quality level, WebP still wins. That's because WebP has ability to blur the image. So at the lowest quality, where JPEG really becomes very, very blocky, WebP, as the first step, works in a fundamentally similar way to JPEG, but then applies blur that covers up all the blockiness, and it looks nice and smooth. But it's in the low quality range where image is still visibly distorted. In the high quality range, like the top of this chart, top half of this chart counts as high quality. The roles reverse, and MozJPEG is actually smaller than WebP. This is because when you want to have high quality, the blurring of WebP starts to backfire. When you save JPEG at the quality high enough that the blockiness is not readily visible, then JPEG becomes good at representing all the fine textures, all the subtle noise, and it gives you an image that is very close to original, while WebP still continues to blur out everything and cover up what it thinks are image distortions. So that's a real-world example where comparing images at the lowest quality where distortions are visible is not representative of performance at the high quality where you don't want any distortions to be visible at all. And let's do another comparison. BPG is an image format based on H.265, the latest video encoder. And that one blows away everything. On some images, BPG is the half size of WebP and beats MozJPEG and everything else. The only problem is in in most of the world, it's kind of illegal to use it because it's patented. So you would have to buy a license for H.265 algorithm to legally use it. And out of curiosity, now that I have tools, I can check all those myths and suggestions how you compress JPEG. So for example, if you blur a JPEG, does it make the file smaller? And looking at it closely, in the lowest quality, if there's like 2 pixels difference, and yes, at the lowest quality, blurring a JPEG makes the file actually a little bit smaller and improves your quality compression ratio. But before you reach decent quality, you're just ending up with a blurred image, and you gain nothing from that. So here's one myth. Another one is if you double the number of pixels in the image, just in Photoshop, resize to 100% the image, and compress it in JPEG at half of the quality, it's called compressive image trick. Is that good? Well, that's the green line here, and it loses out to regular JPEG, so no. You're better off, if you care about having best quality for the given file size, you're better off just saving the image at exactly the resolution you need. Right, so with tools like DSSIM, where you can compare images, those plots are from GNU-plot, but you can use Excel as well. You can create those curves, and for every technique that somebody tries to sell you, for every service, for every tool, for every new image format, you can check this. Does this really improve? Does this improve for the quality I care about, or does it just improve for the blog post that sells the format? And you can really know the difference. So to recap, quality depends on viewing conditions. For example, if you're generating images for Retina displays or 4K displays or any high-resolution screen, the pixels are physically smaller, which means that the distortions are literally smaller as well. And when distortions are smaller, you can get away with much heavier compression, and users still won't notice. Compression for projectors can tolerate everything. Projectors are so forgiving. You don't have to worry about your slides. And for the web, you really, really want lossy formats. The lossless formats, even the best ones, are just working with their hands tied. So they cannot offer you file sizes as small as you can get from lossy compression. And by lossy, I don't mean just JPEG or WebP. Losing quality in any way helps. So for example, if you take a PNG that has thousands or millions of colors and convert it to PNG that has 256 colors, you're throwing away a lot of details, but you're still preserving sharpness of the image perfectly. So there are many kinds of lossy formats, and all of it helps. If you're comparing 2 images, if you want to compare just 2 images, the best way is to compare at exactly the same file size. So just try to tune their settings to come up with 2 realistic images that have file size as close as you can get. And then you can declare winner if either they have exactly the same file size or the winner has both better quality and smaller file size at the same time. Don't benchmark the lowest quality because it's not representative. Most of the codecs are tuned for realistic scenarios, and they fall apart when you take quality too low. And the quality setting in all the tools is just made up nonsense. It's completely arbitrary. So you have to use some other tool for computing difference between images to get reliable scale that is the same across images. And just to finish it off, compressing images, lossy images multiple times, unfortunately, does not accumulate the savings. Because if that worked, you could have all the images at 0 byte size. So unfortunately, when you resave a lossy image, the distortions accumulate for nothing, and the file size the proportion between quality and file size stays the same. So it's best to compress lossy image once, but then if you can apply lossless optimizers that don't change pixels, just pack the data in the file better, then you can apply them after exporting the image, and that's fine. You can apply lossless compressors as many times as you can get. And a bonus slide. What happens if you keep resaving images over and over again? This is after 1,000 resaves. So the problem is not that big. Most JPEG handles it actually well. Smooth areas become smoother, noisy areas become noisier, but it's not too bad. WebP breaks down really badly because to achieve better compression, it has to apply blur and predict one areas of the image from other. So as this is repeated, the distortion spreads all over the file. Right, this is 3,000 recompressions. Cool. So that's it for what I had for today. You can find me on Twitter, Kornelski, or you can check out a collection of image optimization tools that I'm working on at imageoptim.com. Thank you very much.
Is this going? Yes, it is. Right, question time. Who's got one? I've had some sent in, so we've got plenty of questions. There we go.
I'm just wondering, on your quality versus file size or bits per pixel, whatever it was, does it depend much on the type of image? Do you get different relationships depending on the type of image?
Yes, the compression depends on the type of the image very much. For example, P in JPEG stands for photographic. So JPEG is really excels at photos, but anything else that is not easily classified as a photo doesn't fare that well. So yes, if you're benchmarking images, benchmark on actual images that you're intended to use, because the relationship between quality and file size will look different depending on image.
Thank you.
Next. Do you put your hand up while I'm sort of like extricating myself out of it? No, no more?
Okay.
Can't believe it. Oh, Andy's gone.
So wait a second. So you'll ask a nicer question. But another thing that some of the formats do, they store color at half of the resolution. So for every 4 pixels, they average the color and store it just as one hue for the 4 different pixels that only differ by brightness. You don't notice this on photos because photos don't usually contain such sharp edges. But if you apply that type of compression to text, colorful text, ad banners, that's the most popular one on the internet, then they get visibly distorted.
So you talked about BGP, and there's obviously FLIF as well, but there are real challenges getting browsers to adopt new image formats. I was going to say how far, but that's probably the wrong question, are there still improvements to be had in our current JPEG encoders and our other image encoders that can still give us quality or push quality at lower file sizes still?
Right. So there is still room to improve. Maybe not even necessarily with better image compression formats. What I'm currently researching is automatically deciding quality, because as you've seen in the graph, the difference between the best and worst format for a given quality is not that big, but the difference between very high quality and very low quality image is huge. It's like 10 times difference. So getting the right quality setting for a given image might overall save you more data. That's one area where it can be improved. Another area is deciding quality per image. Because if you compress an image too much, you'll probably find that most of the image is fine, is just one or two things that you really care in the image that are really, really bad. So if we could find those two things and avoid compressing them too much, we could still offer you even smaller file. So there's still a lot of room to improve regardless of file type. And I think maybe in 5 years, we'll see an explosion of different file formats where, thanks to something like ASM.js and WASM and service workers, it will become practical to have your own image format on your own website. I'm not sure. Maybe it'll work like that, and then yeah, we'll see a rapid innovation in image formats.
Martin at the back.
Hi, Kornel. Do you think it will be ever possible for browsers to have streaming image decoding? So when you load a website, just 10% streamed, like instant showing website, and then over time it downloads more, showing sharpness and colors?
Yes, the streaming that you describe is already possible today. And I know Tobias from Akamai is working on a prototype of that. So this property is part of the progressive image format. That's one thing you need. The other side of the coin is you need to have HTTP2, because HTTP2 gives the server enough control to decide which part of the image file gets served when. So yes, we're going to see that, definitely.
OK. I need to put my glasses back on for this, but we've got a question that's come in over Twitter from Canada. So you probably know who that is. Right, yeah. So it is Henri, yeah. Right, so basically the question is that you mentioned not being fooled by marketing. Can you mention, without naming names, oh, hang on, don't send me more questions while I'm trying to read the last one. An untruth or a skirting of the verity about compression results that you've come across?
No, I won't be pointing because myself, I would be kind of guilty of that as well. Because when people don't know this stuff, it's so easy to sell it.
Right. Okay. Got any more from the room? But do just stick your hand up thing. But here's another one. Right. So regarding JPEG 2000 and its codec, should art direction be taken in consideration in file type use, considering their codecs?
I'm not seeing so much art direction used on the web yet, so I don't have a strong opinion on that. From the perspective of the file format, it might not even matter that much. If you can serve two different files for different cases, that's fine.
OK, Henri, I hope that answered your question. If not, tweet me back.
Hi, thanks for your talk. It was great. I have a kind of an extended question on the quality. You kind of touched on this a few times. The quality is very personal feeling. And yes, you can put some numbers behind it. But first of all, the quality of the room or the environment makes a difference. The quality of the screen makes a difference. The resolution makes a difference. But also how different colors compress makes a difference. So red over compresses or compresses badly with JPEG. How can you measure that? Or what's your approach to measuring, giving kind of most unique, unified results of that? All of these.
So my tool DSSIM works in LAB color space, which tries to be uniformly perceptual. So it should notice that red overcompression in JPEG. That overcompression in JPEG is simply a bug in the encoder. It's a long story that starts with black and white television, where they had to add color signal in a way that did not break black and white TVs using analog circuits. So the color model that was invented for that then got carried over to digital television, to the MPEG standard, and to the JPEG standard. So the color, and because JPEG is that, all the newer formats also use very similar or even exactly the same color model. So everything suffers from that we couldn't do precise math in analog circuits half a century ago.
Okay, I've just got a general question. It's sort of like really more an industry style question of that I've come across problems where image rights holders, right, kind of, they are really persistent in like saying that we do not want our images put out on your website with like, you know, any loss of fidelity or anything like that. So yeah, okay, you can go down the lossless route and stuff like that and try and go that way to get some form of compression. But are there, with the techniques that you've used, or any tooling out there that where, you know, a website owner could go back to that image rights owner and say, look, this is, you know, you have to be kind of less pedantic about that demand on having like that's just like no loss of fidelity whatsoever. Is there something out there that could help in that situation?
So that sounds mostly like a people problem.
It is it definitely is a people problem.
So
it's dealing with it, but it's dealing with people.
It's never good to solve people problems with technical solutions. The closest you can get that I can recommend is use ImageOptim, which has lossless optimizer for JPEGs that will reduce it by 5, maybe 10%. And that's the best you can do if you really, really promise not to touch any single pixel in the image. Other than that, maybe you could negotiate that you're going to take that quality setting in JPEG 5 or 10 notches, which might actually halve your file size, especially at the very, very high qualities. In JPEG, the file size grows exponentially. So even if you can negotiate a little bit of that quality, you will save
the argument that I try to use is, again, the generic performance argument of actually, you know, size actually ends up with better business metrics at the end of the day. So if you want more views of your image and all that kind of stuff within the infrastructure of the site, actually reducing the page weight just as a generic thing.
Another thing you could recommend to your photographer is that they don't use the magnifying glass to find those distortions. I've seen them do that, like zoom 400, and oh yeah, this pixel is wrong. If the image looks okay at the normal resolution, maybe a little bit zoomed in case some people zoom in your website, then negotiate having okay quality for that zoom, because it does influence how many distortions are noticeable.
Any more questions from the audience? What? Right, okay.
Do you think AI can be used to improve the algorithms that are used in compression?
Yes, yeah. I think so, and I will be working on that. ImageOptim has recently graduated from just being my side project to being a proper company, and I'll be working full-time on improving compression and using AI for that.
Okay, that right. So, oh no, Dom at the back. That's all right. For our international viewers.
So on that subject of AI, and I think really what we're talking about here is different types of image, and what most of us experience probably is that JPEG cliff is in a different place for different images. There are quite a lot of proprietary services out there that are, you know, well, a bit snake oily. They give us your image and we'll give you something back, and some of them are quite good. My understanding is, from kind of little hints and tidbits you can get, is that that's what they're doing, right? They're doing adaptive stuff about different areas of the image. Is that where we're going really to get the improvements now, do you think?
Yes, adaptive quality, I think, is a big thing. So services that can do that can save you a lot of bandwidth. And some services are just using regular JPEG encoder and are saving your images at half the quality. And hey, smaller file size. That's what most mobile operators do with unencrypted traffic. They just take JPEG and recompress it to half quality to save data.
Yeah, I really enjoyed your talk. It's been quite interesting. But I want you to actually clarify something you did say earlier, make sure I did really understand it. When you see different compression levels in the different tools, it's just a load of rubbish. It's what they want it to be rather than any set standard of compression. for example, like 70% doesn't mean 70% in Adobe or in another tool will be 70% would be the same.
That's right. The settings across programs are different and arbitrary, and they sometimes control even different aspects of the same image format. For example, in Photoshop, when you change the quality from 50 to 49, Photoshop will halve the resolution of color in the image, which makes the file smaller. It's like a huge jump for this 1 point inequality. With other tools don't do that. Or ImageMagick has the same boundary at 90%. Most JPEG or CJPEG from the old libJPEG has a completely separate setting for quality of color from the setting for overall quality. So yes, the settings in different programs are different, and the scales are sometimes very different.
Okay, so taking that one step further, based on what you've said, it makes sense to take your baseline approach, but then apply it to different products as well. So you've effectively got a matrix view of it, and then you can make your best judgment based on that.
Yeah, there is a program called JPEG Archive and ImageMin, and they are JPEG compressors that use more advanced concept of quality and try different quality settings in JPEG, and then use another tool to pick the one that actually gives the best file size to quality ratio, and to give consistent quality across different types of images. So with JPEG Archive or ImageMin, you could have more reliable, more even quality for a very diverse set of images.
I think that's quite interesting, that last question, because I think the 70% figure is just so kind of like well known as a rule of thumb.
Yeah, and it's not a percentage of anything.
That's the big takeaway I'm taking. I didn't actually realise that there wasn't a basic standard.
Yeah.
I have noticed in different products that 70% gave me different results.
Yes, and when you look very technically under the hood, what happens in those files, they don't even have a single quality setting. It's just a nice fiction created for users. For example, in JPEG, there are 64 aspects of quality. It's called quantization table, and it controls different levels of sharpness for different size of details in the image. So that one slider that you use actually controls 64 other sliders and tweaks them up and down.
OK, I think that's it. So I'd just like to say thank you once more to Kornel for a fantastic talk, and I hope you've all enjoyed it. It sounds from the number of questions that we've had that everyone has been really engaged by the talk. So thank you, and I'll probably see you in Amsterdam.
Okay, thank you.
Right, so that'll kind of call end to proceedings regarding talks and stuff. So just a reminder that Adam will be talking next month on the development of the LDNWebPerf.org website. So again, looking forward to that one. Please stay along, have a beer. Pizzas will be here a little bit later. I could have ordered them a little earlier, but that doesn't matter. You can have a drink first. But thank you all for coming, and hope to see you again in the coming months.